Hey, and welcome. In this video, we're looking at the process of commuting and associating terms in equations and expressions to help you solve them. So let's just go over the commutative and associative property. So the commutative or the commuting property has to do with moving terms back and forth. So if this person here is a term, right, and a term is something in an expression or equation, a value separated by addition or subtraction, and we'll get to that in a moment. Just imagine we're commuting numbers, right? If this person's a term or a number and they go from here to here, right? They're commuting, let's say, from home to work, right? The word commute is to travel, or if you're a commuter, you commute to work. You go from home to work, you're still the same person. Nothing has changed, and then you can commute back home, and you're still the same person, hopefully, right? So when you're commuting, going back and forth, nothing's changing. And that's the idea of the commutative property. The commutative property says, okay, we can move terms around, right, for addition and multiplication. So it's a commutative property of, I'll abbreviate, plus addition and x for multiplication. So the commutative property of addition and multiplication says you can take terms, let's say a and b, and add them. In either order, you can commute them back and forth, and the value won't change for addition and multiplication. So the associative property is also really useful. The word associate, or who you hang out with or group yourselves with, let's say we're at a party, we got these three people. If these two friends are hanging out, and then the third friend joins them, they're still one big group, right? Nothing's changed. And if I reassociate them, so these two friends are hanging out first, then the third friend joins them, they're still the same group in the end, right? That's what the associative property tells us. No matter how we associate with our numbers together, as long as we're using addition and multiplication, the values won't change. So associative property of addition and multiplication. So if it's all addition or all multiplication, we can associate them in any way. So if you have a plus b, those two terms are hanging out first, a and b, and then we add c, that's the same as having b and c added in the same group and then adding a, right? And the same is true for multiplication. A times b and then multiplying by c is the same as a times b times c. So b times c first and then a. And these properties are so valuable, and we're going to look at some examples to understand that. Before we go on, though, let's talk about terms. Terms are values, numbers, variables separated by addition or subtraction. So if I have 3x plus 2y, in algebra, 3 times x is written as 3x, and 2 times y is written as 2y. These are both terms. This is a term, and this is a term, because they're separated by addition and subtraction. And furthermore, if we had the numbers 3 plus 2, 3 and 2 could be thought of as terms, right? Because they're both separated by addition. When you have a situation, let's say it's 3 times 4 plus 2 times 5. Well, 3 times 4 is a term, right? Just like 3 and 2 were terms, and 2 times 5 is a term because they're both separated by addition. This process of identifying terms that are separated by addition is so valuable. And, let's look at some basic examples. If I gave you, let's say, 1,000, right? And then I said plus negative 17,855. And then I said add negative 1,000. So before we talk about how easy this problem really is, let's just find the terms. This is a term, right? This is a term right here. And so is this. Might be a little confusing because we're adding and subtracting, or we're adding negatives, but the idea is that the terms are numbers or values separated by addition. So we have 3 terms, and just by seeing 3 terms, almost ignoring the number value for a moment, we can start to think, is there any way we can move these 3 terms around to make life easier? Well, if I move this term next to this one, if I commute them together, I have a much easier problem, right? I have 1,000 plus negative 1,000, which is 0, right? Those are opposites. And then I add negative 17,855, which is the answer. So we can look at, first you have to find the terms, then you commute them to make your life easier. The same can be done with the associative property. Make the problem a little bit easier. If I have negative 17, right, and then I'm adding, let's say, I don't know, 17 plus 14,111. If we simply use PEMDAS, we would automatically add in the parentheses, but we can reassociate. So first of all, again, you've got to find your terms. So here's a term, right? And here's a term as well, and so is this a term as well. Now you can't ignore the parentheses, but since we have all addition, we can associate these terms any way we want to. And I want to associate these two terms together first because they're opposites. So we can rewrite this as negative 17 plus 17. Let's associate those two together first, and then add 14,111. So this is 0 here, and our answer is 14,111. And I know, you don't need parentheses here because you would just work from left to right. But I'm showing you that once you identify terms, think about how to commute or move or associate, regroup the numbers to make the problem a lot easier. So I'm going to write out an example, and I encourage you to write it with me, and then pause the video, and then try and solve it on your own. Because it's just a great example, I think, because it's one of those examples that looks so complex, and yet it's just so simple. Again, pause the video. Can you solve this on your own? So the first step for me is to identify terms, things that are separated by addition. I don't usually circle them like this because I guess of course I've trained my eye to do this, but I'm going to circle them for you so we're very clear. These are both terms separated by addition. This whole thing right here, the whole parentheses, is also a term because it's all tied together by multiplication. Plus 180, so 180 is a term, plus 97, plus negative 1/2, negative 1/2 is a term. We have minus 13 over 17. I'm going to write it as plus negative because I want to have the ability to commute and associate terms. So I'm going to write everything in terms of addition or multiplication if possible. So here, minus 3 squared times 20, again, plus negative 3 squared times 20. And that one's tricky, we'll come back to that one. And then instead of minus 17, I'm going to write plus negative 17, so I can commute this term. So now I want to find terms that add to 0. Remember, any opposites add to 0. And opposites are numbers that are positive and negative and the same distance from 0. So for example, 1/2 and negative 1/2. Well, here's 1/2, here's negative 1/2. Add them up, we get 0. They cancel out. They're opposites. Negative 13 over 17, positive 13 over 17 are opposites as well, right? The same fraction, same distance from 0, just positive and negative. So now we've eliminated all of the immediate opposites. So what I would do, especially if I'm new at this, is rewrite what's left. It's a little bit less cluttered. People often don't want to rewrite, but I suggest you do for more complex problems. You can keep track of it. So here we rewrite, and you'll see already how much clutter we've gotten rid of in this equation, right? Plus 180, plus 97, plus negative 3 squared times 20, plus negative 17. So there are no other terms that add to 0 immediately, or obviously, I guess I should say. But what I would begin to do is evaluate our bigger terms, the nasty looking ones. So we have this term right here, and this term. So when you're adding, you're looking for opposites, because you want to get 0, the identity element of addition. But when you're multiplying, you're looking for 1s, because 1s are the identity element of multiplication. So with fractions here, let's look at why this is so valuable. If we have, let's say, 15 times 1/14, that's not too helpful. I'm going to commute these numbers inside the parentheses to make it a lot friendlier. So 1/14 I see here and 14 here. So we have 1/14, 1/14 times 14, and then 15 and 15ths. So times 1/15 times 15, and then 17ths and 17. 1/17 times 17. I'm going to reassociate them, and we can do that. This is all multiplication in here. So now this is much easier to deal with. 14 1/14 is 1. Think about it. 14 times 1 is 14, divided by 14 is 1. Same thing here. It's 1, and the same thing here. But remember, you're multiplying them all. What's 1 times 1 times 1? That's just 1. Now I rewrite the entire equation. It might seem tedious, but necessary, especially when you're beginning. So this whole term is 1 plus 180 plus 97, and I want to evaluate this term now. So we have negative 3 squared times 20. 3 squared is 9 times 20, and it's negative 9 because here you're subtracting 3 squared. So remember that. You're subtracting 3 squared. So whatever 3 squared is, you're subtracting it. Since 3 squared is 9, we're subtracting 9. So it's really negative 9 times 20, or 180. You might be thinking that it's negative 3 squared, which would be positive 9, but you would write that like this, negative 3 in parentheses, the whole thing being squared. But we don't have that here. We have minus 3 squared. That's a tough one. So that's 180. Evaluate that, write it down here, and then plus negative 17. Now, oops, sorry, I made a mistake. Negative 9 times 20 is negative 80, so it's plus negative 80. So now we've got enough information to solve the problem directly, because I noticed that this term and this term are opposites. They cancel out. And what we're left with is 97, negative 17, and 1. I'm going to combine 97 and 17. They both have 7s. They'll be easy to work with. So combine 97 and negative 17. It's just like 97 minus 17. This 1 over here, don't forget it. 1 plus 97 minus 17. I think of 97 minus 17 as 97 minus 10. Sorry, minus 7 first, then minus 10. I subtracted 17 in parts. 97 minus 7 minus 10? Whoa. Well, 97 minus 7 is 90. Minus 10 is 80. 80 plus 1 is 81, our answer. So just to go back quickly. First thing we wanted to do here is remember that the commutative and associative property work for addition and subtraction. Tell us if we can change the order of terms, that's the commutative property, and group them however we like whenever we're dealing with only addition or multiplication. Terms are just values separated by addition. So whatever problem you're given, identify the terms. And then look for terms that add to 0 if you have addition, and terms that multiply to 1 for multiplication. Then, as you regroup, right, the goal is to make the problem simpler until you can easily solve it. Thanks.